Good morning, good afternoon, good evening, everybody. Happy New Year. Happy 2018. May 2018 bring you everything you're looking for this year. As always, I'm Yuri Grinshteyn, and we are GCP Live. It is my pleasure and honor to be joined by Anthony once again.
Hey everyone, I'm Anthony Bushong. I'm Google Customer Engineer based out of San Francisco, lovely San Francisco. So we want to welcome you wherever you're joining from. And yeah, it's 2018. It's a big deal.
That's right. Again, thank you everyone for joining us. We're coming to you from San Francisco. And today we are talking about the 1.9 update to Kubernetes, which I know there's been a lot of interest in. Inevitably, whenever we talk about Kubernetes here, we always get a ton of interest. I see we already got questions on the chat, which we're super excited to get to. But Anthony, 1.9, if you could summarize this update in just a sentence or two, what would you say about it?
Well, I think so KubeCon was or KubeCon North America was last December, hosted in Austin, Texas, and Kelsey Hightower, the face of Kubernetes, I think he had a great keynote where he summarized project updates as boring, and that's awesome because I think that in the past, a few minor releases, we'll see like 1.6 brought something huge. It brought control of Kubernetes, and that's something that really makes it enterprise ready, and really a lot of hardening for production is brought to Kubernetes by features like RBAC. In 1.9, not sure that we really see any brand new spanking shiny things, but rather just a lot of improvements, refactoring, and updates to the project, which makes it, it's really a sign of stability and really the sign of that the ecosystem is now going to be able to pick up a lot of what is being developed and just make the growth parabolic. So it's pretty cool.
That's awesome. It's really good to hear that. I think you're absolutely right. As we see more and more Kubernetes adoption, we're starting to realize that the features that are there are the things that people are looking for. And at this point, really, it's just a matter of ironing out the wrinkles and making things more perfect. So with that, let's get into it. I'm gonna let you take us through some of the interesting things in 1.9. And as you can imagine, I'm gonna have lots of questions about it.
Cool. Yeah. Well, let's go into it. Did you pin my slide?
Yes, sir. Go right ahead.
Awesome. So this is just a quick short list of what's new in 1.9. I think let's start with, I kind of grouped it together in themes, but really what we're seeing is stability for workloads. So the first is that the workloads API and everything supported by that is now GA. And so the workloads API it supports Kubernetes constructs like deployments, replica sets, daemon sets, stateful sets. And these are all ways that you can deploy specific containerized applications into a Kubernetes cluster. And it's basically a set of controller that will enforce how those applications are deployed, right? So if we have daemon sets, for instance, this is typically used for things like Logstash or Fluentd to capture logging and then write it to somewhere else, some type of backend, right? And so that declares that each one of those, one will be running per node. And so it's a controller that's making sure that this specific pod that you're defining is running on each specific node. So each of these constructs all fall under the workloads API, which is now GA. So I mean, it's something that, again, it's a sign of the maturity of Kubernetes. There's been more than a year's worth of people using these Kubernetes constructs to deploy their applications, and now they're generally available. And it's just a sign of maturity for the project. So it's awesome.
Yeah, that's awesome. Really cool to hear that. So again, as we've said a number of times on this show, Anthony is the expert, and I'm here just to ask the questions. So I imagine there may be other folks on this session with us who really want to understand, make sure that we kind of clearly understand exactly what the workloads API is, especially now that it's GA, now that people can start using it. And it sounds like what you're saying is it's basically a way to for folks to get better control over kind of what's running on various nodes in the cluster.
Exactly.
So if there are specific things that need, for example, access to backend resources, maybe things like access to storage, then you can actually control using the workloads API where those pods are going to be running.
Yeah.
Did I get that right?
It's just basically a way. So if we're talking the atomic unit is pods, which is just one or a few containers, the workloads API has many different ways to ensure how those pods are deployed, right? So for stateless workloads, you may want to use a deployment, which defines number of replicas as well as a roll and update strategy. And so when you deploy that, a replica set is created, and then those are kind of just distributed across your cluster. And sure, it gives you some control. There are ways to ensure what nodes those are running on, but really it's made for stateless tasks. If we are talking about some type of message queue or some type of database where you need ordinance and stable identity, that's really where stateful sets come in. So it's a way to really just, there are different methods and controllers to ensure that the specific way that these pods are being deployed are done so. Is Kubernetes all about, kind of driving towards desired state. And so those controllers each define different desired states.
Awesome. Yeah, and at some point, I'm not sure if you want to get into this now, we should probably talk about, why someone might use, let's say, the workloads API to control that versus things like, node affinity versus things like taints and tolerations.
So, yeah, I mean, the best part is you can actually use those kind of in tandem, right? So if I have a deployment, but maybe I only have a certain amount of nodes, for whatever reason, it could be because of the hardware on it or something like that. And I can actually, in my kind of deployment spec, define things like node affinity, right? So I can provide what's called a label, just a key value pair, where I have that defined, and then we'll search for matching nodes with that respective key value pair and then schedule accordingly. So you can use all of these custom controls to get even more granular, right? So I mean, your base like deployment doesn't come with like kind of no specifically defined node affinity, and so you can kind of enhance the way you're deploying your applications with these features. It's pretty cool.
Awesome. All right. So I think that covers the workloads API. Let's move down the list.
So Windows support has moved to beta, and Windows support is something that I believe has been around in 1.5. And so seeing it move, and anyone who's familiar with Kubernetes is that once something moves into beta, it really aren't typically a lot of major changes made past that, just more of hardening and seeing and anticipating more real-world use before moving into GA. So this is something that I think is pretty cool, as I'm not a Windows expert myself, but the ability to have, let's say, something that is OS agnostic, let's say like Go or .NET Core, being able to run that on Linux or Windows and ensuring that Kubernetes supports both, that's pretty awesome. Another cool thing is that it does support Windows Server 2016 containers and Hyper-V containers. I think Hyper-V is just a little more lightweight, but to see that support for those type of workloads will really expand usage of Kubernetes. And I think it brings the whole theme of hybrid to a whole other level.
Yeah, I'm sure that this is something that a lot of our multi-cloud customers are looking for.
Yeah.
Obviously, there are folks out there that do have a heavy on-premise footprint of Microsoft technology. They might be looking at Azure.
Yeah.
So anything that we can do in Kubernetes to make it easier for them to adopt Kubernetes everywhere, obviously, is a great thing.
Awesome. And then let's move into the what's really exciting for me is where I see 2018 is a lot of people will get excited about extensibility in Kubernetes, right? And so that's I'll quickly talk through some of the major things that I see in that theme. Let me know if you have any questions here. I think one of the things is container storage interface. It's pretty cool in the sense that we're providing a way for other storage providers to develop plugins to use, like, let's say something like, I don't know, Minio object storage, for instance, have that natively available to Kubernetes for like application blobs or container images, rather than having to work in and integrate with the main Kubernetes code base. Now with this interface, they can develop their plugins as just pods and then deploy that and interact with the storage interface to make their storage available to Kubernetes applications. The cool part about that is that we're really kind of decomposing, let's say, the different pieces of Kubernetes and making them, so making storage providers and other people who want to extend Kubernetes more agile in the sense that they're not having to merge into the main tree, but rather being able to develop independently and then, let's say, just deploy in a pod, it interacts with the CSI. So that is an alpha, and cool. I think that'll bring just a bevy of different storage providers and, again, growing the ecosystem, as I mentioned.
So speaking of extensibility, we have a question on the line asking about when is Kubernetes going to support voice commands?
Voice commands. So actually, there are plenty of keynotes that, again, Kelsey Hightower has at conferences where he's actually built Google Assistant applications to interact with kubectl and interact with clusters. So it's I think if you look from HashiConf, PyCon, I think those are a couple ones that just come to mind, but definitely go check those out. Or even his latest KubeCon keynote. And again, that's yeah, if you want to talk to your Kubernetes clusters, I mean, check out those keynotes first.
Awesome. Yeah, I think the answer always is if you're looking for someone who's really pushing Kubernetes to its capabilities and beyond, Kelsey Hightower is usually at the top of your results.
Oh yeah,
when you're searching for that sort of thing.
I'm a little worried if some people sleep talk, production error caused by someone saying a command in their sleep. But no, that's funny.
Awesome. Yeah. Very cool. All right. So next, what do you got for us next?
Cool. So I'll jump to the third bullet there. Custom resources in general are really cool in the sense that, like I said, the workloads API will provide a handful of patterns that you can use to deploy containers in your Kubernetes cluster. But sometimes some of those patterns don't suffice for what you need, right? So I think one of the coolest examples is Kubeflow, which is something that that we open sourced for running TensorFlow on a Kubernetes cluster, irrespective of wherever that cluster is running. And so one of the pieces of it is a custom resource. And so this is a way to use kubectl to interact with resources that may not be defined by a deployment stateful set. For instance, I think Kubeflow uses a custom resource that job. And so this is something that requires state. And so while we do have stateful sets, are designed to run forever. And so what if you need something that needs state, needs a master, needs workers, but let's say it's something that's just a long-running job and it'll just run to completion, such as like training a model in TensorFlow. That's something where a custom resource has been written so that you can actually interact with this resource using kubectl, using the Kubernetes API. And so again, that's something where custom resource validation, being able to let users know why something failed, that has moved to beta, and it's really just custom resources in general. I think is a trend we're going to see for many releases moving forward. So that's the custom resource definition. We'll provide some info to read on and for people to experiment with after this.
Very cool, thank you. Yeah, you just brought up something that I'm hearing more and more people are looking to get into, which is TensorFlow on Kubernetes.
Yeah.
Lots of reasons to do that. Obviously, scalability. The speed with which things can spin up nodes, and train models at scale. That's something.
Yeah, and I think that there's we'll put the changelog in the description too. But I think there was updates also made so that GPU or I think the just hardware accelerators in general were more. I think they're working out some of the kinks. In Kubernetes. So it's definitely going to be a trend moving forward. And then the last thing I wanted to talk about is just admission control webhooks. Those have moved into beta, and so this is something where you can actually have the API server submit a request to a webhook to actually allow or deny or validate a Kubernetes resource being created based on, you can pretty much write the webhook to do whatever you want. So what I have in this demo is something that is, so this is actually just the example webhook, the admission control webhook on the Kubernetes doc site. And so what this does is it makes sure that objects or resources being created in Kubernetes come from the Google Container Registry. It just does that by matching a string for gcr.io, right? And so Kubernetes engine cluster, where I have this webhook up and running, and I have two types of, or actually three applications that I deployed. One is a non-GCR deployment, so this means the container is coming from somewhere else other than Container Registry, and we can actually see that here. So this is just a basic Nginx container, and then I have a front end and back end deployment that are both coming from Container Registry. And so what's cool about that is that we have actually extended the Kubernetes API. Typically, the Kubernetes API will, let's say, validate based on its own type of, goes through predicates and priorities before scheduling a workload. But in this case, I actually externalized something that I wanted to see before allowing a Kubernetes resource created. And so this deployment was rejected while the other two were deployed successfully into my cluster. So it really just goes back into the extensibility thing. Rather than having to have Kubernetes and the core code base cover a lot of the edge use cases, now we can just use things like external admission control webhooks to bring in the type of behavior that we want. And so we can, the whole community can begin to develop things independent of that core code base to meet their use cases. And there's a lot of edge cases out there where, we want to, I think the Kubernetes project wants to provide people the resources and the ability to customize the Kubernetes cluster the way they want.
So. Yeah, so I love that idea of extensibility, of giving more power to the end users. As always with any open source project, that's where the power really lies, is the folks that are actually going to be not just adopting the technology, but then really making it do what they want it to do in their environment based on their requirements. Exactly. Not just like us telling them, here's the thing, go use the thing the way we use the thing. Everyone's environment is different, everyone's requirements are different. And we've seen this model just works really well with just software in general, right? The idea of extensibility, the idea of people being able to write their plugins to do the things that they need to do, but then also actually creating, like you said, an ecosystem where people can write plugins and either publish them as open source technology or in some cases even commercialize them. I think just really enriches that ecosystem, that landscape. It makes this tool in the end just much more powerful.
Absolutely. And there's a ton more, again, we'll just put the changelog into the video description, as this is just what jumped out to me and what I wanted to let our audience know. But yeah, I think the last thing I had is also wanted to speak to specifically Kubernetes Engine, which is our managed Kubernetes solution. And just to note that regional clusters are now in beta.
Yeah.
And this is super cool because it's something where,
So tell us what regional clusters are.
Yeah, so regional clusters is the idea of having a multi-master configuration for your Kubernetes cluster. And so one of the trade-offs that people have had to experiment with before, or not experiment, evaluate before, is that if you're running GKE, the default used to be single master. So that means when there's an update, something like that, you may experience brief downtime, right? And so some people are constantly deploying multiple times in an hour, and so they can't afford to have that kind of window of downtime. And so a multi-master configuration is much more suited for their use case. And so now with GKE, you can actually create regional clusters, and this is something that's in beta where we actually set up 3 masters for you to ensure that, 1, there's high availability across failure domains, so specifically zones, and then 2, that as you kind of update or use GKE to update your control plane, that you don't have any downtime because you have that high availability. And I think it's something that ultimately is going to be table stakes for Kubernetes, and so it's really awesome to see GKE with this feature.
And as you can imagine, the one thing that people really want to know is, when is 1.9 going to hit GKE?
I am not privy to that. I'm not on the product team. I imagine very shortly, GKE historically tracks the minor releases very closely. So we're excited to see it.
Okay, very cool. And then, so speaking of regional clusters, have you seen folks actually go from upgrading, basically, I guess a zonal clusters would be what what's available today, and move that to a regional cluster? Is that an option?
So I'm not sure if you're looking for like an automagical button where you can just click and then it'll
usually that's what I'm usually looking for.
I'm not sure that exists yet, and that's something, again, probably you want to keep an eye out for. I think really the thing is ideally, that's the beauty of Kubernetes, is that you have what you want deployed, kind of it's predefined in a way that it can be moved and deployed into different clusters. And so that's kind of, unfortunately, I haven't seen that yet. I don't know, can't comment on the roadmap of it, but I think that, Kubernetes does make it easy to deploy something that was running in one cluster and deploy it to another. So.
Okay. Very cool. All right, man. Well, thank you so much.
Awesome.
Let's wrap it up. And this time we'll stay off the table so that we don't get any camera shake.
Fist bump for the camera.
Good job, man.
Surprised the camera didn't shake with that.
Yeah. Folks, thank you so much for joining us today. Really appreciate it. Thank you very much for being here. Thank you for bringing much needed GKE and Kubernetes expertise too.
Oh no, I mean everything
to our show.
Everything I'm doing, I learned from a lot of other amazing people. Like Ahmet, he's a developer advocate for GKE, and so he made this cool little comic that we're looking at right now.
I love it.
A ton of awesome people that work at Google that have just been part of the community for years, and I think it's like, really tap into those resources because they they're awesome, and they've been providing thought leadership for like 2+ years now. So yeah.
Thank you so much once again, folks. Thank you so much. Really appreciate it. As always, subscribe, like, leave us comments, follow us on Twitter. And I believe that we'll be back next week with a session dedicated to using GCP for rendering workloads. So very different topic, but should be very interesting as well. Thanks again. And again, it's our first show of 2018. I think we're very excited about what's coming up on GCP Live for the rest of the year. So thank you.
Happy New Year.
Happy New Year, and have a great week.